Okay, so these are the topics so far that we've covered in this unit. I'm just this. Sorry. Yeah, that's not going to sound good. And we will be reviewing. I just had a request to make that a chart that we had a long time ago. Remember, like with the FF prime, F double prime? It's like a little, and I think that's a good idea. So I don't know if you have a little room on that page. We can do this. This is the key to happiness in life. It really is. If you get this, oh, that's a good screensaver. So let's try this. So if a function is increasing, what do we know about the derivative? Positive. We don't know anything about the second derivative. If all we know is the function is increasing, because it could be going concave up or down and still be increasing. So if the function is decreasing, negative. What if the function has a relative max? Positive to negative, right? The slopes are going positive to negative. If the function has a relative min, negative to positive. Now, if you understand this, the relationship between f and f prime is the same as the relationship of f prime to f double prime. So we can basically copy these two columns, just shift them over. Okay? It's the same thing because the second derivative is the derivative of the first derivative. So we just go right here. So, if the first derivative is increasing, what do we know about the second derivative? It's positive. If the first derivative is decreasing, second derivative is negative. If the first derivative has a relative max, second derivative is changing from positive to negative. If the first derivative has a relative min, the second derivative, negative to positive, is changing from negative to positive. Okay, well, with the second little group of information here, we can pull it back and say something about the function in each case. So if the slope, the first derivative is increasing, so the second derivative is positive, what does that mean about the function? Concave up. If the first derivative is decreasing, making the second derivative negative, what about the function? Concave down. If you're looking at the graph of it, yes, of that thing. If the second derivative is changing sign because the first derivative has a max or min, in either case, what does it mean about point of inflection? The function has a point of inflection. That's it. If you're going to get a tattoo, this is what I suggest. This would help you at least. Right there? That would be good. Yes. Sure, absolute max and min, you have to check out the y values at any of the relative maximins and the endpoints. And then you have to get the y values and compare them. Just take the greatest or smallest y. Yeah. Yes. Yeah. Okay, let's take a look. Hi. Sure, take them. Riley. Wake up, Riley. Wake up. Another one. They're just dropping. I'm just losing on my kids. Okay, let's talk about the homework. Now, guys, I gave you the answers to the homework in your notes today. If you take a look, but I thought I would. I really want to go over, your questions. So you might want to check, see how you did. We'll look at the 2006, the one with the calculator first. We'll look at the calculator one first, the 2006. Does anyone need to borrow a calculator today? The first thing that I would do with a problem like this, if it's a calculator question, I would enter it into the calculator, put it into Y1. That's supposed to be an E. It got a little blacked out. But you make sure you're in radian mode. And then the other key thing is when you have a calculator question, they've given you the equation, make sure you have the right window. So what you have matches the picture they have. Like, so if I look at this graph that they gave me of f prime, the x's go from 0 to 3. So I set my x min at 0, my x max at 3. And the y min -1, y max 1. That way I get this same picture on the same graph on my calculator. Okay, so let's take a look at these. So the first part of this question was nice, right? They say to use the graph of f prime to determine whether the graph of f is concave up or down on the interval from 1.7 to 1.9. So you look at it, on that interval from 1.7 to 1.9, the first derivative is decreasing, right? So what does it mean about the function? Concave down. Okay. So we didn't even need to use the calculator too much. Yeah, you have the answers, so I don't have to write them all up. Now, for the second part, anytime you're asked for the absolute max or min over an interval, those always take the most work. Okay? So they wanted you to find where the absolute max was. So first thing you have to understand, like, what numbers could be. What are the candidates, What do you have to check out? Endpoints, and anywhere the derivative changes from positive to negative. Okay, so if you want to find where the function, again, you're looking at the derivative, not the function. You want to know the function has an absolute max. You have to find out the y-coordinate of the function at the endpoints, so 0 and 3, and anywhere it changes sign. Well, the first thing you had to find is where is this changing sign, because they didn't label it. So if you wanted to use the calculator to do it, you have to go to your calc menu, choice 2, where it says 0. So you'd want to enter your function into y1 and go to calc menu choice 2, where it says 0, and it's going to prompt you for left bound. You go to the left of it, hit enter. Right bound, go to the right, hit enter, and then guess. And you should find that 0 is 1.7724, that number over here. Now, I knew I was going to have to use it, so I left the screen and stored it in alpha A. You don't have to do that. That's just nice, when you get an ugly number. You hit second mode, quit, and store it. If you didn't want to do it that way with the calculator, to find out this x-intercept, you could have set the function equal to 0 and solve it. And when you if you're trying just to solve this without the calculator, if you set the function e to the negative x over 4 times sine of x squared equal to 0, e to anything's always positive. That'll never be 0. So the only way the product could be 0 if the sine of x squared equals 0. Now, do you know, think of your unit circle. Let's think about what this angle x squared could be. The sine of what angle is 0? Give me an angle. The sine of what angle equals 0? Well, we'll start out at 0, so yeah. But we already knew that it was 0 here, so that's not going to help us. What is the next angle for which sine is 0? 180 or pi. So the next time, so that means that x squared could equal pi, would equal pi. And so x would be the square root of pi. If you didn't want to do this, that's what they're getting on that answer sheet that you're looking at. Square root of pi is the exact answer, but it's a calculator question. You can just be accurate to 3 places. Okay? Okay, but here was the big part. So now you know you got to find the y-coordinate at the endpoints and at this, for the derivative went from positive to negative. How do you get f of a value? This is not one of those definite interval ones. You got to use the starting point. Remember the starting point for this one? What did they give you? Yeah, they told you f of 0 is 5. So if you want f of a, you start at f of 0, and which is 5, and you add the change. How do you get the change? Yeah, the integral of the derivative. Now, I've already got that derivative stored in y1. I'm just going to write y. I'll just write f prime of x. You integrate the derivative from 0 to a, or if you wrote 1.77, then you go to your calculator to get it, right? You put in your calculator 5 plus math 9. Again, I've got this derivative stored in y1, so I just type y1. How do I get that to show up? Bars. You go to the right one and it says y bars, then function in y1. You can type it again, but sometimes, you don't want to make a mistake typing it. If you've done it once, it's good. So we get that's 5.679. Then we want to get f of 3. We got to start with the starting point, right? So we're going to start with f of 0 again, and we'll add the definite integral from 0 to 3 of the derivative. And you want to save time. When you're on your calculator, if you already have this typed in, hit second enter and just go back and change this a to a 3. You don't have to type the whole thing in again. When you hit second enter, it brings it back, whatever was on your screen last. You can keep doing that until you want to edit something. So now you just have to compare the y coordinates at the endpoints. We had 5 and 5.57 to the y coordinate at the relative max, 5.67. And the greatest one of those occurs here at a at 1.772, the square root of pi. Got it? Those do take a while because you got to get the y coordinates at the endpoints and where the derivative changes sign. Okay, and just the other one. Yes. It should have been 0 to square root of pi because it's 0 to. Well, that's the 1.772 number. Okay. If you, how would you know that's the square root of pi? You wouldn't just looking at that. But the only way you would know that is if you solve this. You got the zeros without the calculator. You just set the function equal to 0 and set each factor equal to 0. So e to the negative 4x is always positive. That's never 0. The other factor sine of x squared equals 0 when the angle x squared equals pi. So x is the square root of pi. Just, yeah, make sure you go out enough digits because your final answer has to be accurate to 3 places. So I would go out further. That's why I like storing it because it gets, it gets the whole thing in there. Yes, 3 places after the decimal. So that's what your final answer has to be accurate to. Always, yep. No, that's fine. As long as it's accurate to 3 places, that's fine. Any more is fine. Okay, see, write in the equation the tangent line to a function f at x equals 2. This has got to be, you just got to know this. To write the equation of a tangent line to a function f at x equals 2, y minus f of 2 equals f prime of 2 times x minus 2. So then the questions are, you have to get f of 2. We get f of 2 the same way we were getting those other values. We took f of 0 plus the definite integral from 0 to 2. Right on the calculator. But here's one I don't know if you know how to do. Usually getting f prime of 2 is really easy with these problems. You just read the graph. But if you look at the graph, it's not obvious, oh, well, when x is 2, what's the y coordinate? Have you ever used the calc menu choice 1 value? You have used it. No? Okay, if you have a graph on your screen, let me just go to it. Okay, let's say, let me just clear that. Yes. If you have a graph and you're wondering, oh, what's the y coordinate when x is 2? Because you can't just trace and think, oh, that's going to be good enough. Oh, it's around this. Never. Trace is never good. Okay? You have to use second calc, option 1, and you just tell it what's the x. 2. Enter. That's the y there. All right? It'll give you the y coordinate anywhere. So negative 0.459. So that's the slope of your tangent line. And that's how they got that answer on the sheet, So it's y minus 5.623 equals the slope, which I lost, it was at negative 0.459 times x minus 2. And you leave it in point slope form. Yes. Yes. Yeah, the table is great. Sometimes you're not going to have the x value you want, and you got to set the table. So as long as you're able to do that, that's great. Was that the last one of this one? Okay. The other one, you are given a graph of the derivative again. Every time they just say, hey, here's the derivative, they absolutely have to give you a starting point. All right? With those other ones, the accumulation functions, they don't. Right? Because you can just plug a number in. Here. For the first one, nice. You're looking at a graph of the derivative. They say find all values of x for which the function has a relative max. What do you look for? No, not an absolute max over a closed interval, just the one in a relative max. Changing from positive to negative. That's why the answer is negative 3, because you read it left right, positive to negative, and x equals 4. Your justification is a function has a relative max when its derivative changes from positive to negative. You just say that. That's your justification. Right? Final values of x at which the graph of f is a point of inflection. What do you look for in the derivative? A function has to think of that chart we did a little while ago. When the sign of the second derivative changes, but this is the first derivative. Relative max or min. When the slope of f prime changes sign. Okay, so you could say either one, but you see that the second derivative is this guy's slope, so it's going from positive to negative, right, at negative 4, at negative 1, and at 2. So you can say the second derivative, a function has a point of inflection when the first derivative has a relative max or min. Or you can say the function has a point of inflection when the sign of the slope of f prime changes. When the slope of f prime changes sign. Okay? Or goes from increasing to decreasing. You could say that. Just want to be clear. Oh, this was kind of fun. Find all intervals in which the graph of f is concave up. So what does f prime have to be doing? Okay, so increasing, positive slope. So we want to find the intervals where f is concave up, so f prime is increasing, and where the function has a positive slope, so where f prime is positive, right? So we just got to look where it's increasing and has a positive slope, and where it's increasing and positive, so where it's above the x-axis and increasing. So negative 5 to negative 4, and 1 to 2. And the last one is the one that took the time, because if you're looking for an absolute min, it can occur at the endpoints or at a relative min, where the derivative changes from negative to positive. So you had to get the y-coordinate not only at the endpoints, but at whenever the derivative goes from negative to positive. Oh, just one. Oh, good. I thought there was 2 in here. I gave myself too much room. Okay. Don't forget, they give you a point on here. They told you what f of 1 is, so that's done. How do you get f of 5? Yeah, it'll be 3 plus, because it's going to be f of 1. You got to use the point they gave you, plus the definite integral from 1 to 5. So yeah, this will be 3 plus, and we're going to do area above minus area below for that. Same thing here. It's going to be f of 1 plus the definite integral from 1 to negative 5. But for this one, you're going to switch the limits of integration and make it minus. But for both of those, what do you have to find? Areas. All right. So you have the area, 1/2 pi r squared here. What's the radius of this guy? 1. So it's 1/2 pi times 1 squared, or half pi, pi over 2. Area of this semicircle, 1/2 pi r squared. So 1/2 pi, what's the radius of this one? Right, times 2 squared. So that's 2 pi. Now, do you want to keep this as one big triangle, or you want to split it up into two? Split up into two? Oh, I heard one still, so. We'll do one? All right, I'll do one this time. So 1/2 base times height. So we're going to do 1/2, the base is 3, the height is 2. So 1/2, 3 times 2 is 3. And the area of that last triangle, 1/2 base times height, is just 0.5. I got to put that in there. It's 1/2 base times height. Okay. So, because for this first one, it's 1 to -5, we'd have to switch them, which means we'll have to do minus. Oh, not there. Oops. So we'll have to do 3 minus area above minus area below. Some kids just like to, when they have to switch it, just do area below minus area above. Just keep it. I don't know. All right, so 3 minus from between 1 and -5. I'm keeping it minus in front, so we'll do area above minus area below. Pi over 2 minus 2 pi. So that would be -3/2 pi. So if we subtract -3/2 pi, it's 3 plus 3 pi over 2. So far we have a y coordinate of 3 plus 3 pi over 2 and 3. And how do we get, and this one, f of 1 is 3. Definite integral from 1 to 5. What's that going to be? That one's nice. 2.5. Area above minus area below. 3 is the area above. You look at the graph between 1 and 5. Area above minus area below is going to be 2.5. So f of 5 is 5.5. So you're comparing these y coordinates. You're looking for the absolute min. And so the smallest of those would be 3. But the questions, oh, it does say find the absolute min. So the absolute min of f is 3, and it occurs at x equals 1. Okay? You starting to like them? It's not bad. All right, so you guys are going to start working on this. When you do this review sheet, the first one, try to do it without a calculator. I got the mean value theorem and the average rate of change. The second two, do with a calculator. Yeah, it's like 1, find the average value, and then 2, find the average rate of change. Yep, let me just turn this off.